I'm going to do the second one, video on the washer method. I'm actually going to return to the region we did in the first video. So I just returned to this drawing here. We have the region formed by y equals the square root of x and y equals x squared. So we have that pictured here. We have the intersection 0, 0 to the intersection 1, 1. The difference here is instead of rotating about the x-axis, we're going to do two rotations. The first one we're going to do is what if we take that region and we rotate it about the horizontal line y equals -1. Okay, so what's going to happen here is we take that region and rotate it all the way around here. This isn't going to be the same shape at all. This is going to have a hole in it. Almost, I guess you could think of this as almost looking like a lampshade, right? So the outside would be sort of like this. That's formed by the square root of x around this line, okay? And then it's going to have a hole in it here, okay? And then our axis of rotation, y equals -1, will look like that. And then we have this outer, or excuse me, formed by the inner part of this would be the y equals x squared. So once again, we are dealing with a washer. Basically, whenever we rotate, there's only going to be two options. It's either going to be solid, and we're going to use that disk method. So the disk method, I want to remind you, is the pi integral from a to b of little r squared dx. And so that's if it's a solid disk, or it's going to have, the cross-section will have a hole in it, and it is going to be a washer, which would be a to b big R squared minus little r squared dx. Okay, so those are really going to be the two options we're going to see here. So once again, if I kind of think of this as being like a lampshade, does that work? So this is going to have a solid all the way around, and then it's going to be completely hollow inside. Okay, so if I want to find the volume of this, once again, we're going to do the same. The methods are always basically the same, whether we're talking about a two-dimensional shape or a three-dimensional shape. We're going to slice this up an infinite number of times. Okay, so we're going to have a washer. So if we think about taking this thing and putting it out here, we're going to have a washer, all right? And the big R is going to come from here to our axis of rotation, okay? So our big R in this case, once again, a thickness of dx. The big R in this case is going to be the square root of x, and then that's going to be minus -1. So we're actually adding 1, right? Because it's going to be minus whatever's on top minus whatever's on the bottom. So it'll be square root of x minus -1. Little r will be formed by the x squared to our axis of rotation. So it'll be x squared minus -1, okay? And that's our little r squared. Really, that's the key to all of these, okay? So when we're talking about a disk, we just find what our 1r is. When we talk about a washer, it's a matter of finding what the big R is and finding what the little r is. It's pretty basic. Whatever function is farthest away from your axis of rotation is going to form your big R. Whatever is closest to your axis of rotation will form your little r, okay? So we're going to see this switch when we do our second one. So for this one, our big R is, so anyways, let's put this together. So A, that's going to be 0 to 1. Big R, so that would be square root of x plus 1 squared minus our little r, that would be x squared plus 1, that quantity squared dx. We'll calculate these here in a moment. All right. So that is if we rotate about the line y equals -1. Okay, what if we rotate about y equals 1? So let's erase what we've done here so far. And let's change that axis of rotation to y equals 1. Okay, now you'll notice that it does touch in one point if I rotate around y equals 1. That isn't going to throw anything off because at that point everything will zero out, and we don't really have to focus on that. Let's say we rotate around y equals 1. Okay, so the same region, okay, except we're rotating around y equals 1. What is that going to look like? So we're actually returning to a shape that looks very similar to what we did before, right? In the part 1, so we get something that on the outside kind of looks like a hemisphere, okay, as we rotate around that axis. And then if you look inside of it, it's going to have a hollowed out look. Okay, so this would be on the inside. Okay, so once again, our cross-section has that hollow, so we're talking about a washer. And just in your mind, think it's either going to be solid disc or it's going to have a hole in it and it's going to be a washer. So now I'm going to slice this thing up. Okay, I'm going to use my okay, so same type of thing here. I'm slicing this up with a thickness of dx. And now we're just going to look at what this is. So here, let me erase some of this. We remember this is y equals squared x. I don't need that there anymore. Okay, so what's my big R going to be? The big R is formed from y equals x squared. That's my big R here. And once again, if you ever get confused, your big R is always going to be formed by the function that's farthest away from your axis. Now, instead of going functions minus the axes the way we did with y equals -1, now the axis is above. So remember, it's always going to be whatever's on top minus whatever's on bottom. Kind of like what we do area between curves, right? When we do area between curves, it's always the function on top minus the function on bottom. So here, my big R is going to be 1 minus x squared. My little r, which is right in here, that's the hollow, is going to be 1 minus square root of x. And that's really it. You just have to figure out what big R is, what little r is, and that will do the trick. So let's put that together. Okay, so pi, 0 to 1. Big R will be 1 minus x squared, that quantity squared, minus, and little r, that'll be 1 minus square root of x squared dx, and that will be, if we rotate around y equals 1. So if this was closed calculator, it's likely that we would just leave it like this, but let's calculate these using our calculator. So let's go ahead and use our Math 9. So 0 to 1. You want to be very careful with your parentheses here, so I'm going to put this, make sure you put this in parentheses. Square root of x plus 1. That 1 should not be under the radical. Squared minus, and start another parentheses, x squared plus 1 squared, and enter, and we're going to get 0.9666, and let's say pi, okay? Let's just go ahead and calculate this. And I don't actually care how you represent these. Whether you put them in terms of pi or not is up to you. Just make sure you're accurate with 3 decimal places as always. So that'll be 3.0368. Okay, so that is the volume of this solid rotated about y equals -1. Let's do the other one. So 1 minus x squared and 1 minus square root of x and hit enter, and 0.3666 pi, or if we multiply that by pi, we're going to get 1 point, or 1.1519. And that is washer method. So once again, to sum up, when we do these rotations, don't overcomplicate it. It's either going to be solid, your cross-section is either going to be solid like we saw in the first video, which would be a disc method, or it's going to have a hole in it, which is going to give us a washer method. If we do rotate around another axis other than the x-axis, keep in mind the big R is always going to be formed by the function farthest away. The little r will always be formed by the function that's closest. If we change whether the axis is above or below, if the axis is above, it'll be axes minus functions, like we see in B. If the axis is below, it'll end up being functions minus axes. So that's washer method.